Welcome to the discussion. We are looking at a question on sequences and series, geometric progression. The question we have reads, the second term of a GP is 6 and the fifth term is 48. Find the common ratio and the third term of the GP. For the GP, we know to get the nth term, we use the formula for the nth term, that is A, you multiply by R, n minus 1, where A stands for the first term and R stands for the common ratio. We are told the second term of the GP is 6. The second term is given by A multiplied by R, and this second term has been given as 6, and the fifth term is A R raised to power 4. Since n is 5, so it is 5 minus 1 giving us 4, and this fifth term is 48. So the first thing we are supposed to do is to get the common ratio, and for us to get the common ratio, we take the fifth term, you divide by the second term, and this one is going to be equal to AR raised to power 4 divided by A multiplied by R, which is going to be equal to 48 divided by 6. A is common and therefore it cancels. We are going to remain with R power 4 divided by R, which is going to be equal to 48 divided by 6, giving us 8. Applying the rules of indices, we are going to have R power 4 minus R power 1, which is going to give us 8. Or you can simply take R power 4 divided by R, giving us R cubed being equal to 8. And for us to get the value of the common ratio, we take the cube root of 8, which gives us 2. Having gotten the common ratio, we can go ahead and get the first term, which is represented by A. Using the second term, AR is equal to 6. We know A is the first term and the common ratio is 2. So if you take A, you multiply by the R, which is 2. This one will be equal to 6. Dividing both sides by 2, the value of A is going to be equal to 3. Having gotten the first term and the common ratio, we can now get the third term. And we know the third term is given by A R power 2, since our n is going to be 3. A has been given already 3. We multiply by the common ratio, which is 2 raised to power 2. Remember, this is 3 times 2 power 2 is 4, giving us 12 as our third term. Thank you for watching and welcome to our discussions. And in case you're watching this channel for the first time, please take 1 second and click the subscribe button.